Whether you find them tucked away in basements or placed on top of roofs, chillers help keep the occupants of certain buildings cool and comfortable. They function similarly to an air conditioner, but they have a few crucial differences that make them more efficient for use in larger buildings. To understand why they're better suited for certain structures, let's look at how chillers work, starting with the refrigeration cycle. Essentially, chillers use refrigerant to collect heat from a building and reject it outside. The refrigerant is continuously processed through a cycle, but let's say the cycle begins at the compressor. The compressor pressurizes the refrigerant, which greatly increases its pressure and therefore its temperature. The added pressure is also what drives the refrigerant throughout the system. After the compressor, the refrigerant moves on to the condenser. The condenser is where the refrigerant rejects heat collected from the building. The different types of condensers will be discussed in a bit, but for now it is important to know that the refrigerant leaves the condenser at a cooler temperature. At this point, the refrigerant is ready to be depressurized and used to absorb heat from a building. Once the refrigerant leaves the condenser, it reaches the expansion valve. This valve depressurizes the refrigerant, much like covering the end of a garden hose with your thumb and letting out a fine mist of water. The loss of pressure causes the refrigerant to dramatically drop its temperature, making it ready for the final step of the refrigerant cycle, the evaporator. Inside the evaporator, which is shaped like a tank, chilled water runs through metal tubes that come into contact with the cold refrigerant. Sometimes the refrigerant goes through the metal tubes instead of the water. This contact allows the refrigerant to collect heat from the chilled water before the water leaves the evaporator. Afterwards, the refrigerant travels back to the compressor and begins the cycle all over again. There are two different types of condensers used in chillers, and the difference lies in whether a chiller is air-cooled or water-cooled. In a water-cooled chiller, the condenser is a tank like the evaporator, but this time water absorbs heat from the refrigerant instead of the other way around. The condenser water then travels to a cooling tower, often located on a rooftop, where the ambient air cools down the water before it returns to absorb more heat. In an air-cooled chiller, on the other hand, the condenser is not a tank, but instead a series of coils containing the refrigerant. In this case, the chiller is stationed outside. The unit's fan pulls ambient air over the coils, which cools down the refrigerant before it reaches the expansion valve. The entire purpose of the refrigerant cycle is to collect heat from the chilled water and to somehow reject the heat outside. So, once the chilled water leaves the evaporator, where does it go? Well, that depends. In industrial applications, the water can be used to cool specialized equipment or manufacturing processes. But for commercial applications, the chilled water often goes to an air handler unit. Inside the air handler unit, air comes into contact with the coil that runs the chilled water. Much like how an evaporator cools water inside a chiller, the coil cools down the air that eventually enters the open space of a building. The chilled water, now warmer from the absorbed heat, returns to the evaporator to be cooled down once again. These are the mechanisms that allow a chiller to efficiently cool down mid to large-sized buildings. The refrigerant cycle is the exact same as that of an ordinary air conditioner, but the general efficiency of a chilled water system makes it better for larger buildings.